Alright, so last time we talked about compositions, and that actually relates really well to what we're going to be talking about today for the first time, which is inverse relations and functions. Okay, inverse relations are where you take the domain and range, and then you're able to switch the domain and range. So the range becomes the domain becomes the range, and you just work that way. Okay, the inverses just work just like what we've been talking about. If you see a plus, do a minus. If you see a minus, do a plus. Everything that just works right there. Okay. Now, if I wanted you to find out what the inverse was, I would probably write it out like this: y to the -1 equals question mark. Okay, so how do you find the inverse of an actual equation or function? Well, what you do, step number 1, switch x and y. Okay, step number 2, solve for new y. Step number 3, you're done. Simple as that. Now you can check your answer, but you're going to have to do this one method I'm going to talk about. Okay, so what we do is we switch the x and y, so the x becomes x equals 3y squared minus 5, and just work that way. So I'm going to add 5 to both sides, so this becomes x plus 5 equals 3y squared. I would divide everything by 3. X plus 5 divide by 3 equals y squared. And then what I'm going to do is I'm going to square root both sides. And yes, you are going to have to think about the plus or minus version. So all 241, all 251 of x plus 5 divided by 3 equals y. Okay. Alright, so that's how you do it. You just do the inverse operations. Okay, and the best way to do it is to just work with this. Alright, now one of the ways to really check your work is to go ahead and graph it. So it's y equals 3x squared minus 5. Okay, there's our actual graph. Now, y equals the positive, we'll put positive, and we'll do square root of x minus or x plus 5, and we'll divide by 3. Let's go ahead and get rid of this. There we go. Alright, now right off the bat you probably can't see it as well, so we need to graph the negative version as well. So y equals negative square root of x plus 5 divided by 3. Okay. Now if you can kind of see a pattern, that's because whenever you do an inverse correctly, when you graph them, they're going to kind of look symmetrical. Not exactly. They kind of look alike, but they're not exact until you graph over the y equals x line. Now if you turn your head about 45 degrees to the right, you can see a symmetrical picture made by these objects. And guess what? They will intersect at y equals x. And that's one of the most important things that leads us to the idea behind actually how to see if we check our work to see if we did it correctly with inverses, and that's really kind of cool. So you could actually graph this stuff to just check your answers to see if you did it correctly. Alright, so to check work by hand, plug the inverse into the original, and if you get x as your answer, like you literally simplify and everything, you did x, you're halfway done to proving that you found the inverse. Okay, now the next thing you have to do, okay, the next thing you have to do is to Alright, next thing, you take the original, plug it into the inverse, and if you got x, you found the answer. Now, what do you mean you got x? Like literally, you got done simplifying the composition that you just did. So remember, this is compositions, okay? So when we plug in our composition is going to be our inverse into the original and then the original into the inverse. If we get x each time after we're done simplifying, we have the inverse. Personally, I like graphing with Desmos and just graphing y equals x at the same time to see if I have a symmetrical pattern. But you can also check this too, okay? But that's it for solving inverses and finding them. So just remember, follow these rules by hand, and then to check your work by hand, follow these rules. Otherwise, graph on Desmos. Both inverse and original function along with y equals x and see if you have symmetry. Okay, and that's all you have to do. Thank you guys very much and have a wonderful day. Bye.